Let x1, x1, so xn be a random sample from a Poisson distribution with parameter lambda greater than 0. Which of the following statements are correct in the respect of likelihood ratio test? So the first statement, so generally if we consider like x1, x2 and so on xn, so if they're having like Poisson distribution with parameter lambda greater than 0, so in the question we are asked about the relationship between likelihood ratio test, Neyman-Pearson test and UMP or UMPU tests. So first if we consider like this Poisson distribution belongs to one parameter exponential family with the sufficient statistic t is equals to summation xi. So and this family also has like monotone likelihood ratio in t, and it also has like complete and sufficient statistic t. So therefore if we consider like for regular exponential families, so this likelihood ratio tests are always functions of this sufficient statistics, and for one-sided alternatives we are having, so this LRT coincides with this UMP test, and for two-sided alternatives this LRT coincides with this UMPU test. So if we consider the first statement, so the first statement says h naught lambda is equals to lambda net versus h1 lambda is greater than lambda naught produces UMP test identical to NP test. So this is true because we can see that this is MLR, so monotone likelihood ratio in T, and so Neyman-Pearson lemma here gives this rejection for large T, and thirdly, like